Hello, in this screencast I will give you an introduction to FASTEN. You can download FASTEN from the GitHub page of the project. The zip contains a collection of domain-specific languages built on top of the input language for the verification tool NewSMV using the MPS language workbench from JetBrains. You don't need any of these tools to download separately, they are contained in the package. After you download the zip, unpack it, go in the bin directory, and you can start FASTEN. FASTEN stands for Formal Specification Environment. When FASTEN starts for the first time, nothing will be shown but this window. In this window you can choose to either create a project or open an existing one. I will show in the following how to open the tutorial project of FASTEN. So you navigate to the installation directory and then to the tutorial project. Just please remark this black rectangle there, which means that this directory contains a project identified by MPS. The very first time when you open the project, the following screen is shown. You see the user's manual of FASTEN. The user's guide is in this second solution, and it contains one chapter per each big feature of FASTEN. Examples containing FASTEN code are in the first solution, in the NewSMV tutorial. Each of these models contains several examples of FASTEN which showcase different features. So let's have a look. The first model contains examples using the base language, the input language of NewSMV. We have simple models here describing different systems. You can of course run these models once you have the main module. So let's run it. NewSMV was called, it was executed, the property failed, and here we see the counterexample which caused that failure. Besides the NewSMV code per se, you can also describe source files and run these as well. So this source file executed NewSMV over the semaphore project, and it contained two properties which passed. Let's go further and have a look at some more interesting extensions of SMV. The first extension is a language for writing tests. For example, if we have a module here, the counter cell, which takes an input parameter carry in, and it defines an output carry out. Then we can write several test cases which represent input vectors and the expected outputs. We can execute a test either individually or the entire test collection. One test in this collection failed, and if we press F5 we have an editor refresh which shows us which test failed in which step. If we go further to a more complex example, this would be an emergency stop, which takes two inputs, the step input and the stop command. And what the system needs to do is to stop immediately after the stop command was received and stop counting. For this we also have tests, which are in this case generalized tests. The generalized tests contain values for the inputs and the expected outputs. Star means any input, any value for this input in this step, in step 4, is acceptable. What do we write here? We write here that after the stop command is true, then the output is no more valid, independent on other commands which come or on what the step parameter is assigned to. Let's look a bit closer at this star. If we open the inspector here, we see that the star has a type boolean, and here we can define the possible values which the input is allowed to take. Let's run the test from this test collection. a test fails, F5 again, and we see that this test fails because, of course, as expected, when stop command is true, then we expect that the output is not valid anymore. A next extension of FASTEN is presenting architectures. Very often you have modules which represent composite systems or architectures. In the notation menu, you can choose between different projections, different views for the architecture. I'm projecting now the architecture in the textual view, and you remark that architecture is a simple module which has an input and contains a wiring section. The wiring is a special kind of var section which also has some restrictions. So as parameters of the instantiated modules, we allow only constants or input parameters or parameters of the output ports of other modules instantiated here. Please remark that the modules which are part of the composition have special defines which are outputs. How do we get that? So by simply here creating an output. Let's turn back to the graphical notation. You can choose to edit this using either textual notation or the diagram palette. So in the diagram palette you see the different parts of the architecture. In this scope we have two modules, the sender and receiver, and we can instantiate this again. So let's drag and drop and then connect the ports. S2. Now if we change the projection, in the textual projection we remark that a new line occurred and that it represents the newly added element. Having an architecture, we can of course define tests or use different other constructs as we are used to. Our next extension is the state machines. So here is a traffic lights controller system written using the base language, the SMV. So we have a big assign section with inits and next for the timer, pedestrian signal and traffic signal. We can represent this as a state machine. In the notation you can switch between the textual view and the diagrammatic view of the state machine. Let's have a look first at the state machine in a textual perspective. The state machine has a main variable called a state variable which represents the current state. This is the traffic, and several other variables. The main variable is initialized in the initial state, and then we have transitions. Please remark that the transitions are case statements which are labeled. All other variables evolve according to the guard defined by this label. Yellow to red, just control click on each of these elements of these guards and they are live links. I'm changing again in the state diagram view to showcase the notation. You can add new states here. State I added is stopped, and I can add transitions to stopped. By clicking on a state, some buttons will be shown, and by dragging from this plus here I can create a new transition. The transition has a name and then some action. So stopping. If we change again in the textual notation, we see the new state, the stopped state, and the transition here, stopping transition, that is fired from the green state. Another extension of FASTEN is about tabular notations. Here we have a simple example featuring a 1-bit full adder which has 2 inputs, 2 bits as inputs and a carry in. The output is the sum and the carry out. The function table here is actually a specialization of the defined section, and this can be combined with var sections and typical normal assigns. So in this case we have a table which also accesses as conditions the state, the internal state of the module. A more interesting extension is about a generalized test case for special kinds of systems. Let's have a look at this state machine, which seems quite big, in a graphical notation. We remark that this module has different states, and from the initial state it goes in some warm-up state 1 and then in warm-up state 2, and eventually the system comes in running and does something. What we would like to check are properties related to running, so we want to check properties after the system came into running, and I want to write generalized test cases for this. So let's have a look. This is a verification case, a special kind of test cases, which features, in addition to the inputs and expected outputs, the initial condition. So the initial condition represents the state of the system from which this test vector is run. I'm running it. If we want to better understand why a test fails, so let's run it again, we can open this result in a simulator. We have the counterexample here, but we can simulate this counterexample. I've pressed on simulate and then the simulator is opened. Let's have a look at the simulation. I'm splitting the window and you see that the simulator shows the state of the systems. So now I'm going through the step forward button and I see how, or step backward, and I see how the inputs of the system change accordingly. A very interesting extension is about operator panels. An operator panel is nothing else but a model used for visualization. So I'm opening this and reloading adapter classes. If I have a test, I can simulate this test, and when I simulate it, I'm going step by step, and the operator panel widgets from here are linked to the output ports of the module under test, and according to their value the colors here change. So now the traffic lights is in the state where the cars have yellow and pedestrians have don't walk. If we make one more step, okay, then we eventually come in the state where the cars stop and the pedestrians are allowed to walk. Please have a look at some other examples that are here. Do not forget about the user's guide, which guides you step by step through most important use. I wish you a lot of fun modeling systems in a rigorous formal manner using FASTEN.